All right, so normally we'd have a T-chart for this proof. We're on page 48 here, and we would write statements. So let's go ahead and do this for yourself in your module book there. And we would have reasons written down on the left. Now, what's kind of missing for this one is an actual given. But we've already done this proof once before. We talked about the exterior angle theorem when we were taking our notes, and we showed why these two angles add to give you the one outside. And so this is the formal proof of what it would look like, okay? So I just want to highlight a couple reasons that we're using so we know how to kind of write it on our own. The first one we know is that all the angles, so we labeled angle W here in a triangle, all these angles, X, Y, and W, have to add to 180, good. So we can just say the sum or the angles of a triangle add to 180. This one in the book says the sum of the angle measures of a triangle is 180. So if you want to write something down in your own words, you could say something like the angles of a triangle add to 180 degrees. That's totally fine to write. Okay, how do we know that W plus Z is equal to 180? What's the vocab word for two angles that are next to each other here? Marin? Good, so a linear pair of angles, it says supplementary. You could also write a linear pair, okay, add to 180 if you don't want to write out the word supplementary, all right? Notice for the next one, you don't have to write property of equality normally, you can just write substitution. So what we did was we took both of these equations that were equal to the same amount, they're both equal to 180, and all we did was set them equal to each other. So we took the measure of X plus Y plus W, which is right here, and we said that that is going to be equal to the measure of W plus Z, which we put right here. So notice that this is the strategy we're going to be using for the next week or so, is that we're taking two things that are equal to the same amount, and we're setting them equal to each other. And then in this expression, what's the same on both sides of the equation? Good, the measure of angle W. So what can we do to get rid of it? Now remember, just like in our proofs yesterday, we don't actually show this subtraction, right? We don't show that this is going to drop out. Okay, what we normally do is we just show that it goes away and that what we're left with. But behind the scenes, we're actually doing some subtraction. And notice that our next reason says subtraction proper equality, which is what we did in our equations, okay? So even when you subtract something to cancel out on both sides of the equation, we're still going to write that subtraction property of equality. Does this make sense to you guys? Okay, we're going to do some more of these. So let's go to the next page. And these ones we're going to do together. Okay, so right off to the side here, let's do a little T-chart. Go up here. And I'm going to call this line here that's right here, I'm going to call this L, and I'm going to call this M. So the given for this should be, okay, that lines L and M are doing what? They intersect. And that is going to be our given. Okay, so what do we know about these angles? Now our job here, our proof statement is going to be that the measure of angle X, or just angle X, we don't have to put measure, that angle X is congruent to angle Z. We want to prove that these two angles are equal. Okay, so let's make a plan. What do we know about these angles, W and X, and then X and Y?
X and Y added to 180.
Okay, so we know that angle X plus angle Y is equal to 180. What do we know about Y and Z, by the way, then? Good. Angle y plus angles, not x, sorry. I know we said y and z. We want to stick with angle x here because that's the one we want to get. So what do we know about y and x? They equal 180, okay? Does this make sense? We're going to put this down right here. We're going to move over a little bit and put a 2. I'm going to kind of move over to the left a little bit here to get myself a little bit of room. Actually, I don't think we need to do that. Yeah, we'll do it anyways. So we're going to say angle x plus angle y is equal to 180. I'm going to put a comma, and I'm going to write down the other one too. Angle y, actually, time out for a second. Okay, how do we know that these two angles, x and y, add to 180 degrees? What property, you guys are looking at your cheat sheet there, might you be able to use? Van? Okay, so we would write down a linear pairs do what? Add to 180. Perfect. Okay? Now, is that the same reason that y plus x equals 180? Or do we need a different reason?
Same reason.
Same reason. So we can put a comma and list that in the same step. So whether you want to write it underneath or just right next door, you're going to write angle y plus angle x is equal to 180, okay? So pen in hand, filling in our statements here. All right. Now, John, what was the strategy we talked about before? Do you remember the last proof? We said the strategy was that we want to get two statements that are equal to the same amount, and then set them equal to each other. So when we look at our proof, do we have two things that are equal to the same amount? Right? We have angle y, x plus y is 180, and angle y plus x is equal to 180, right? Does this make sense? Also, what did you notice? Time out. Did we write the same thing twice? Error on my part. Vera, what did you say originally? The angle y plus angle z equals 180. That is actually what we want to go here. We don't want to write the same thing twice. Also, what's the strategy we notice in these two equations? Well, either one. If you put w and x, then put w and z. If you put y and x, put y and z. Okay, does that make sense? All right, what do you notice is also the same in these two equations besides the 180? The y. So what's going to happen? Let's take a pause for a second. Janai said, once I have these two things that equal to 180, I'm going to want to set them equal. So we're going to say angle x plus angle y is equal to, what's the other equation over here that we want to set it equal to? Angle y plus angle z. Perfect. Okay. What's the reason why we can take two things and set them equal to each other? What are we really doing here? Remember what we wrote on the proof on the last page? They put down. Okay, but how do we say that mathematically? You could technically write that down, Nija. We call that substitution because we're essentially taking out this 180 here in this first equation and just plugging in y plus z for it, okay? Now there is technically another reason. If two things are equal to the same amount, this is also called the transitive property. Okay? So the transitive property says, kind of like if I would say, if I have $10, right? And Freeha has $10, then we both have equal amounts of money, right? So we could say something like, if A equals B, makes sense so far, and B equals C, what has to be equal from these two amounts? A and C, correct? Do you guys see how we're just setting them equal because they're both equal to B? That's what the transitive property says, okay? Does that make sense? However, you can always use substitution whenever you could write down transitive. You can't always put transitive when it's equal to substitution now. So when in doubt, write down substitution, because it works. Okay, what else did we want to do? Remember the strategy in the last question? Because I know, right, that I want to get x plus y equal to z, and we saw that there was an angle W on both sides, what could we do? Avery, what do we do to get rid of W on both sides there? We subtract it. Can we use that same approach here? Yeah, because I have an angle Y on both sides, I can subtract it. Now remember, in a proof, we don't actually show the subtraction. We just say what our answer is. So Suzanne, if I take away angle Y from both sides, I'm going to get left with equals. And then what is the property we put down when we do subtract that out? Yep. You got it. And if you go back up to the top there, is that what we wanted to prove? Are we done? That's it. You guys did your first proof. Okay? Does it make sense what our strategy was? We got those two sums equal to the same amount. We set them equal to each other. We noticed that one of the two add-ends, the things we're adding together, are the same. So we just subtracted that out from both sides of the equation, and we got left with our proof statement. Okay, that's going to be kind of a common thing that happens here. Okay, take a look at letter Z. Sorry, letter Z. Number 2. Teacher failed. What do we got? Given the diagram to the right, we want to prove that the measure of angle W plus the measure of angle X plus the measure of angle Z is equal to 180. So far, so good. Elise, what do we know about X, Y, and Z, by the way? Elise? So what about if they're in a triangle? All right, we know that these add to 180. Is there anything else anyone notices about the diagram that'll help us out here?
W and Y are equal.
Why are W and Y equal here, Sadiq?
Because it's two lines intersecting
So what does that mean?
vertically.
Yes, that's what we want to talk about. These two angles are going to be equal because they are vertical angles. So this is what we're going to do, okay, to get our proof done. This is it. We're going to be there. You guys ready? So if I want to do a proof, first thing I need to do is teacher. So we do our statements, we do our reasons, we're writing down our proof stuff, okay? All right, this one says the given is the diagram to the right. So we're just going to write down for the given, diagram to the right. Normally it will be more expansive, like it might say triangle with extended lines, and given. Okay, so what's the first thing we said we knew from the diagram that we wrote down at the top? What do we know about X, Y, and Z again? They add to 180. So we're going to put down number 2 here, Jeremy, that angle X plus, angle X plus, what's the other angles in the triangle? Okay, so X plus angle Y plus, the last angle you said was angle, and those 3 angles, because they're in a triangle, have to add to 180. Perfect. Okay, the reason for that we wrote down before, right? Angles in a triangle add to 180 degrees. We're just kind of explaining the reason for that. Okay, look at the proof statement. What is different about the proof statement from the one that we wrote down for number 2? Vera. W instead of Y. We want to get the Y in here instead of the W. how can we swap these two out? What do we have to know about them before we can swap them out, Elise? We got to get y and w equal. So we have to have a statement, right, before we can do the proof statement that says that angle y is equal or congruent, put the little squiggly line on top for congruent, to angle w. And how do we know that again? Sadiq, you said? Vertical angles are equal. Okay, so now can I just take the y out and replace it with w? Would it make sense that we can do that since they're equal? And what would be the reason that I would be allowed to do that? That's it, substitution. So angle, instead of x, we're going to write angle y, angle w plus angle z is equal to 180. And then for 4, we just put down substitution. Now, are we done? Now, does it matter that they have w plus x plus z and I have x plus w plus z? No. Do we have the proof statement written down for the last step? That's it, we're done. Okay? There you go. All right? So anytime you want to swap things out, when you want to substitute into an equation, we have to have an equation that says they're equal. Does this make sense? Or if we want to set two equations equal, we have to have them equal to the same amount. All right? Okay, let's go down to the next page. Let's take a look at number 3. I'm going to label these with letters. So let's say A, B, C, D, and E for now. Okay. We're going to do, once again, we're going to do our T-chart here. Now, when you do your T-chart, try not to do one of these because you're only leaving yourself with like this little itty-bitty space to do a little bit of work and then all this space over here to write stuff. So try to put your T sort of in the middle of your paper, even if it's like this. Why am I only leaving myself a little space right here? Because I know the first reason is going to be given. So I can use that space for the given, and then I'm going to get more room as I move down. I also am going to make sure I write reasons on the top right and statements on the top left here. Okay, now it says we need to write a label in the diagram that is not labeled yet. So if we look at this picture, what does it look like should be true about this picture? Avery? What does it look like should be happening with this picture? Something I'm currently circling with my cursor here. There's triangles. Hold on to that. We're going to come back to it. Something needs to be labeled here. What does it look like is happening, Snow? Not the angles. Janai? Yes, the two lines should be labeled as parallel to one another. We actually need to know that before we begin. Okay? So what we're going to write down for the given is the diagram with AB parallel to CD, because we've labeled those letters for ourselves, okay? All right. Now, remember, our proof statement is going to be that these two things are equal. Y plus Z, so these two are equal to the sum of these two. Now, Avery, what did you start to tell me before? That there's what in the picture? Come on, you got this. You were going to say something. There are, I'm going to stay right here with us until we're getting to go. That there's, what do we know about the triangles then that helps us out? What's inside of these triangles? I'm just not going to say it. I'm not going to do it. Yeah, what do these letters in the triangle represent? What do we think they represent? Take a guess. Come on, guess. Apples, oranges, bananas, or something that starts with the letter A? Aiden? Angles. And what do we know about the angles in a triangle? They add to 180, right? You knew that. I knew it. All right. So what can we actually say here? How many triangles do you see? What do you think, Vera? 2, right? There's this triangle, that's the small triangle right here. So what angles are going to add together in that triangle? Angle, well, let's use the letters in our diagram. Angle A, right, plus angle Z plus angle Y, that has to equal 180, because we want to end up with the same letters. Does that make sense? So that's why I'm just using those. Really, these letters should be on the outside over here. So just an FYI, you'll see that later on in the diagram. The other figure is where? Vera? The bigger triangle all the way around. This is another big triangle right here. And so what angles here are going to add to 180? Angle, well, hey, A again, right? Plus angle W plus angle is equal to 180. Oh, do we see the strategy? How am I going to get Z plus Y equal to W plus X? Substitute, meaning we're going to write down what? Oh, time out. We forgot to put a reason down. Oh, wait, we already talked about it, right? Is this the same reason for both of these? So I only need to do a comma, right? And then I can just put down one reason for those. So the angles in a triangle add to 180. Perfect. Okay, Freya, you said substitute. So what are we gonna write down to substitute here?
Angle Z plus angle Y equals angle W.
Well, we can't do that yet. If you just said Z plus Y, what are we leaving off? We have to bring that down because we didn't do anything with it yet, right? So we're going to write angle A plus angle Y. Oops. And that has to equal
Angle A
plus.
angle W and angle X.
Perfect. And we can write down for our reason what you said before. Good. Substitution. What's the next strategy here, Nafisa? We can subtract A from both sides. We're not going to show that, but what's going to be the result? Well, what's left on the left side here if I take A away? Plus. And on the other side? And then what was the reason again why we got A to drop out that we can write down? Yes. I don't just want to sound like a snake all day. Awesome. Subtraction, property of equality. Very good. And MD, are we done? Do we have our proof statement down here? So that's it. We're good to go. We done it. We done it. Go for it. All right, let's take a look at number 4. Okay, we're going to try this one together here as well. Now, notice that it says for number 4, in the figure to the right, we have AB is parallel to CD and BC is parallel to DE. These are going to be our givens here. Okay, so we're going to go ahead and start by making a T-chart. So let's see if you guys can do it, and then go ahead and fill in those 2 givens we just talked about. So my T-chart is going to be like that. And then I'm going to kind of cut it here to leave myself room on both sides. And then I'm starting number 1 way over to the left. Not in the middle here, way over here so I have room to write, okay? Even if I'm not using all that room. And then AB is parallel to CD, perfect. And then comma. And then BC, or you can put the word and, is parallel to DE. So these 2 vertical lines indicate parallel. That's the symbol for parallel. Usually when I write them, I just slant them a little bit. And then for the reason we write down given always. Okay, our job is to end up saying this. Now, where is angle ABC? How do we read that angle on the diagram? Right? We start at one of the two letters on the end. So let's say we start at A. I'm going to follow A back till I get to B, and then follow B over till I get to C. Does this make sense? Okay? So that is angle ABC. B is always the vertex, is the middle letter. The other angle is angle, so starting from C, traveling back up the line to D here, okay, and then over to E. That's angle CDE, okay? My job is to show that they're equal. Now, I'm going to get rid of this for a second. Do we notice anything in the diagram that we're allowed to do? Like whenever we see those little arrowheads on the line for parallel, are there things that we should be looking for here? Simon? Oh, can we make a Z?
Yeah.
We can, right? Right here? So what does that mean if we can make that Z?
Then the two inside angles are equal.
All right, these two angles are equal. So let's go ahead and let's write that down for number 2. Now, I can't just say angle C here because there might be more than angle 1 at C and also has 3 letters. So let's use our name. This angle we know is angle, well, that's angle ABC. And that's congruent to this angle. So how are we going to name that angle? We're going to call it, Riona? BCD, perfect. You could have said DCB and that also would have been fine. Okay, any other things that we can write down here?
ABCD is also equal to CDE.
Oh yeah, there's another Z going this way. So these two angles are also going to be equal. All right. Now, question, is it the same reason since we're drawing Z's? Okay, so that means we could put a comma, and then underneath this we can write angle, we said CDE is congruent to angle, oh, this angle right here, that's just angle BCD again, right? That's CDE up here, and that's just BCD again. So what is the reason we're going to write down for parallel lines? I'm going to do more of this tomorrow, but what I want you to see is if you looked at your note packet here, and we went all the way to the last page, where all those fun properties are, for parallel lines, it's kind of annoying, but right down here it says, 2 parallel lines cut by a transversal. Then we have to say what angle pairs are congruent. So the Z makes, what type of angles again? Nija? Alternate interior, nice. So in our module book, number 2, we're gonna write, this is kind of annoying, but we're gonna write, if 2 parallel lines are cut by a transversal, okay. This part of the parallel lines thing is always going to be the same. We're always going to start out with this. What's going to change is what we write next. Now, these 2 angle pairs that we're talking about with the Z are called, Mija, you said alternate interior. And what do we know about alternate interior angles? How are they related? They're equal. So we're just going to say are equal or are congruent. That's it. That's going to be our statement for parallel lines when we make a Z. From here till the exam, that's what we're going to write down every time. Okay? Does this make sense? Does it make sense why we're saying they're equal? Now here's the deal. Why do we have to say if 2 parallel lines are cut by a transversal? Well, what happens if the lines aren't parallel? If I draw the line that cuts through them, if I make a Z, are those angles going to be equal? No. They're only going to be equal if these 2 lines are parallel first. Now the angles that form the Z are going to be equal, okay? So we have to kind of stipulate for ourselves that the lines are parallel first, and then we can say that the alternate interior angles are equal. Okay, now key thing, we want to get ABC, so here's ABC, equal to CDE equal to this angle. Okay, Evan, do we see a way to do that? What do we notice is on the other side of this for both of these little statements? If these angles are both equal to the same angle, what should we know about them then? They're also equal. They're equal to each other. Perfect. So for number 3, I could just put down angle ABE is congruent to angle, well, oh, good call. I don't know why I put ABE. Oh, I'm reading AB and then jump down there. ABC, and then angle CDE. Now, remember, on your note sheet there, okay, when we have two things, you guys see all the way at the bottom right here? If we have two things, A equals B and B equals C, if they're equal to the same amount, the reason why we can set them equal is called the transitive property, okay? So we're going to write that down for ourselves for this statement. That's the formal math term. So we're going to put down transitive property. But let's say I forgot that transitive was a thing. What other thing that we've written down can I also write? I can also put down substitution. Because I can say, well, I'm just taking out BCD and I'm putting CDE in its spot. And then are we done? Because that's the proof statement. We're good. Boom. Okay? That's the proof. Okay? We're going to skip this next one. You don't need to know it. It's a little complicated. All right? So what I'm going to ask you guys to do, actually got 5 minutes left. I will gladly let you start your homework tonight. So remember, your homework tonight is on page, in your note packet, is on page 22. And we're kind of doing the same thing we started with for yesterday. We're doing more of equation based, okay, just for an extra review. So, the first statement, now technically the given should be first, but that's not there, okay? So why is this angle PQR plus this angle RQS, why is it equal to the whole angle PQS? So why should I be able to add two smaller angles and get a larger angle back? This is called, we're going to put down for the reason, the angle addition property.
Are we doing page 23 as well?
Just 22, where it says homework for lesson 9. 23 is labeled, if you look at it, it says module 1 lesson 10 homework. So just page 22. Okay? And then what do you need to do from here? Instead of PQR, what did we write? X minus 5. Instead of SQR, we put down, and instead of PQS, we put, so what would be the reason that we're allowed to do that? Substitution, all right? And then I'm going to let you finish, okay? Finish the rest of this, because you should remember that from yesterday. Okay, hop down to number 2. Pause. Heads up. Take a look at number 2. How do we get this question started? So we have this funky little symbol here in the given. Looks like an upside down T. What does that mean again? Perpendicular, good. Not bisector, but perpendicular. And what does it mean if two lines are perpendicular? And They intersect and create 90-degree angles. So we know that there's a 90-degree angle here, okay? So what is going to be the reason why we can say that 1 plus 2 equals 90? It's because 1, or fill in the blank here. What does this symbol mean again? Perpendicular, and these are lines, right? So we're going to write perpendicular lines. And what do perpendicular lines do again? They form, we could say right or 90-degree angles. So anytime you see that little symbol, that's going to be the reason we're writing down. Okay? And then you guys should know what we're doing from here, correct? I feel like this is wrong. It's a little double step here. Let's do this. I'm going to do this for a second and draw a line through here. So I'm cutting this step into 2 steps. I apologize if this is wrong. This 5x plus 5 equals 90 should be down here. And instead of this being here, what should be here on the top? James? 3x plus 5, good. Good. So I want you to do 2 separate steps for this one, because this is what should be here. Okay? And then see if you can finish this one off. And then the last one, we kind of did one like this already. So you should be able to give me a reason and then plug in from there. Okay? All right. You guys are finishing that up for homework. We'll go over that tomorrow. Have a great rest of your day.